Thank you very much. Yeah, welcome to my session, Model Your Data Like a Star. And I hope you get that pun. So there's a pun. The pun is intended here. So on the one hand, your data model should look like a star, but of course also you should be a star in modeling your data. And already some chat message from Fernando where he asks, one big flat Excel file will do, right? I don't think so. So this is this talk about. So maybe Fernando is the right guy to talk to, how to shape your data. So what is this about? So my name is Markus, and I work with models. And when I explain to people that I work with models, maybe they have like this picture in mind that I work with beautiful people. Maybe I do, but my expertise lies in data models, so like beautiful data and beautiful models in there. So this is me. And if you think about Power BI Desktop was born as a self-service BI tool. So like I don't think Microsoft had in mind that it will ever be so successful as it currently is. So they had like the Excel users in mind when they tried to do things there. And with that, it came with a lot, or still comes with a lot of educated guesses, and it tries to make it comfortable to use and easy to use and helps you. But sometimes like good meaning doesn't really mean it's really good for you. So in some cases, you have potential risks and potential improvements there. And that's the thing, which is hard to tell to people who are not coming from IT. So I'm coming from IT. I'm trained as a software architect, as a software engineer, as a data engineer. And when I then talk to people working like with business problems, which they solve with Excel or then Power BI, it's hard to like tell them this is really important that the data model is right. Because Power BI allows you to use any data model. You can just put whatever you have, this one single Excel file, or like this third normal form 100 table data model into Power BI. Technically, it will work, but you will pay a lot of penalties. So the reports will be slow, the DAX statements will be very, very complicated, and there's also risk that there's some like wrong numbers in there. So it's very, very important to model your data right. I cannot emphasize this too much. And on the other hand, changing the data model later is really, really hard. If you change the data model, you change then like what kind of tables you're having, what kind of columns you're having in which tables. And if you change this will for sure break your reports. So if you discover too late that the data model is wrong, you have also like to rewrite your reports again. And this is hard to do. So get it right from the beginning. So for this agenda, I picked like the introduction stuff. So I don't know anything about you. Maybe you're experts in data modeling, then enjoy your beer. If you're unsecure about things, I hope I can introduce you to this topic. So there's important things like relationships, and I'm talking relationships between tables. It's not about your private relationships. We'll not talk about that. Also get them right, of course, but today we will talk about data models. Then there's this really awful term, denormalizing. I don't like this term, which is like derived from the term normalizing, which is also like doesn't mean anything to me. Maybe it's because English is not my first language, but I don't think like having something being normal. I mean, what's normal today? So this is like, yeah, a bad term, but we'll talk about it because the concept behind it is very important. And then we will talk about the data dimension. This is a very, very important dimension, and there's a lot of things going on in Power BI, which tries to help you. On the other hand, it's not really good to have those features turned on, and we will talk about that. So let's see what 30 minutes to go. I will not overshoot because my working day started already 13 hours ago, so I will try to finish in time in about 30 minutes. So the use cases, we will not talk about them. I will, we jump over the use cases. We just talk about concepts. Relationships. The relationship, if you open Power BI, you have this model view, and everything I'm explaining here, by the way, is also true for analysis services tabular. So no matter if you're using tabular or using like SQL Server analysis services tabular or using Azure analysis services or Power BI, it's all the same. The data modeling, the problems, the solutions are all the same. And you open up the model view, you can see like these tables and there's like these lines in between, and those lines are relationships. And this looks like an ERD diagram, an entity relationship diagram, which is used in database modeling for many years. I would say since the beginning, since 1970. If you think about how old relational databases are, it's amazing. So it was a really good concept. It's still around. And in the database, in the relational database, this is constraints. So if you have a constraint or a relationship in a database between your sales table and your customer table, that means it does not allow you, it constrains what you can insert in the sales table. So you cannot insert something in the sales table with the customer number, which is not available in the customer table. That's what the constraint makes sure. It makes your data quality better. Power BI, Analysis Services Vertipack, does not care about such limitations. You can insert whatever you want. The relationship information in Power BI is the other way around. It's not limiting something in your what you can insert somewhere, but it applies a filter. If you put a filter on your customer table, this filter will then trickle down to your sales table. This is what the relationship is about. So we want to filter, we want to propagate filter between tables. And there's two ways of filtering. There's the single and there's this bidirectional filter. So the filter can only go, for example, from the customer to the sales table, or it could go both ways. And trust me, you only want to have filters going in one way, no bidirectional filter. Only in very certain use cases. We can take this in another discussion about advanced use cases. There you might use bidirectional filter, but the standard, the default should be stay away from bidirectional filter. They will make your model complicated. Maybe you come into a situation where you cannot add another table because then your model gets ambiguous, and Power BI does not allow you to have ambiguous models. So where there's potentially more than one path between two tables. And the other one is the cardinality. Again, not sure about, English is not my first name, but cardinality, even in German, is not really a term I'm using on daily basis. So it's a weird term. And it's talking about, for one row in my customer table, how many rows do I have in my sales table? And hopefully, to one customer, we sold a lot of stuff. So we have a lot of rows there. So it would be the many. So it would be whatever to many relationship. On the other hand, one sales row can exactly be assigned to one customer. We have the foreign key constraint, or the foreign key field in there, which tells me this sale was going to this customer. So we have a one-to-many relationship. Again, the one-to-many relationship, this is what we want to go for. There's also a one-to-one relationship, the two tables, and they have like a one-to-one relationship. I would like model this or try to model this as one single table. It doesn't really make sense to have two tables in here. Maybe there's some use cases if you have like two different refresh algorithms, you want to refresh one of those attributes on a different schedule, then maybe you come up with a one-to-one relationship. And again, the many-to-many is even more dangerous than the bidirectional filter. Try to stay away from that as much as possible. It's not really the classical many-to-many relationship you have in the relational databases. But you solve it the same way. You usually should put a bridge table in between. So one table with a distinct list of the keys, and then have a one-to-many relationship from the bridge table to the two tables which are on the many side in this relationship. Of course, many here means that it could also be the case that for one customer we have only one sale. But this is not what we're talking about. We're talking about potentially one customer can have up to many sales, and that's why the many term is the right one here. And there could also be customers where we did not have any sales right now because it's a new customer. The customer just signed up in our system, and of course, at this point in time, they do not have any sales. But potentially, the customer will have many sales. Let's jump over to the first demo. So I have my. Is it gone? Where is it? Can't find my virtual machine. Here we go. Here's the virtual machine. So I have one Power BI file. This looks like the model view, but it's a report. So just try to mimic the model view. So we only also see like some data. So we have the transaction table. There's an account table, and then I put just this image there to make it look like the model view. And it tells me that there's a one-to-many relationship between the account and the transaction table, so one-to-many. So the star means many. And then we have this triangle here with the flat side pointing towards the account and the pointy side pointing towards the transaction. So this means that the filter is propagating from the account to the transaction. So if I choose one of the accounts, for example, Bill, I will see that this will filter my transaction table. And if I change the filter, of course, this will change as well. And if you delete the filter again, this will then remove the filter from that. On the other hand, if I click on anything in here on one of the accounts, it will not filter the account table because the transaction filter on the transaction table is not propagating through this filter direction. It's against the direction, so it does not filter the account table. And that's the usual thing. So that's what we usually want to have. One-to-many relationship and only going in one direction. Maybe you're thinking, wait a moment, Markus, we are not stupid. If you click on the account here, we can see there's something happening up in the report, right? So if I click in here, it changes actually the numbers we can see here in the amount in my report up there. But that's a different thing, and this sometimes makes it really hard to explain things happening in Power BI because there's so many things just happening, trying to make your life easier, but actually making my life to explain it to you much harder. So there's another concept in Power BI which is not part of the modeling. This is just this feature, the cross filter direction. So if you have different visuals on your screen, you can have that you select something on one visual and it will automatically be propagated from one visual to the other. It has nothing to do with the model. So please be aware if you click something and think about filters are happening, some of them might be happen because of the model view, others might be because of this cross filter happening in the Power BI visuals. For the one-to-one relationship, we could think about there's a customer table and a customer detail table. Customer one-to-one relationships are always bidirectional. So the default is that always the filters being propagated from the one side. If you have two one sides, then of course the filter is going in two directions. So I can filter something here and will change something over there. On the other end, I can filter something here and then it will jump over to the other side. And for the many-to-many relationship, we could think about something like that. So we have like a many side here, a many side here. And again, so this is the same tables like previous, and then we have this new table, the account customer table, again on a many side. This means if I filter on the account table, it would filter both the transactions and the account customer. But if I filter the account customer, this will not be propagated to the account table. And as it's not propagated to the account table, it will not even be propagated to the transaction table. So this is what we get with this bridge table in between. If there are any questions, please just unmute yourself or interrupt me. Grab the microphone.
Any questions, anyone? My first question is, I think I might have to just borrow this for one of my training sessions. And one of my customers needs to go and read this or see this and watch this because the comment would be presenting the model view as a report is making his head hurt. Mr. Grey Skull's head hurt. He runs a company called a consultancy called Grey Skull, and his head kind of hurts. But I actually think it makes a lot of sense. It does make a lot of sense, yeah. I've never seen it presented that way. I kind of like it, and I definitely will get one of my customers who just has one of these. He has an Excel spreadsheet, and he has another one on, and another one on, and another one on, and then he goes, Ben, can you write me a measure, and why doesn't it work? Or I've written a measure, why doesn't it work? Will you go and spend 5 hours debugging this? And I'm just like, oh, don't change your model. So I take your point. Your point that you made early on was the model's got to be right, first of all. And often business people come at this, rightly or wrongly, rightly probably, with the view and just shove everything in Excel and all just work. Yeah, and it's our job to get it to work often as well. Yeah, so they're not wrong. They provide us with money and revenue. Hey, all right, back to you, Markus.
Okay, then let's close this one. So the other one will automatically be opened while I talk, going back to the other slide. So where's the slide? Here we go. So this was relationships. The next thing is denormalizing. As I mentioned that I don't really like the term, but I really like the concept. So before we think about denormalizing or normalizing, think about the naive way of doing things. So if you would ask me, please, Markus, provide me with a list of products and their subcategories and categories, and then the sales amount of the product, then I would just give you one table. That's like the intuitive way, right? A table with 4 columns, one column for the product, subcategory, category, and then the sales amount. And this is a single table. And the single table has a really big disadvantage, and this is redundancy. So if there's one product category on this list which contains more than one product, then the product category name appears several times on this list. So this is bad for, of course, storage, because you storage this thing multiple times in our system. But this is also bad if I want to change it. I have to make sure to change every single occurrence of the product category. Otherwise, I would end up with 2 different names for the same thing in the real world. And I would also have troubles when I want, for example, insert a new category and not having a product currently. So how would I insert that? What would I put in the product name? Null or -1 or unknown or whatever. And on the other way around, if I delete like one product and the product was the last one from a certain product category, I have to be careful. I cannot just delete it. I just have to empty it out because I want to keep the product category, right? So there's a lot of problems with the single table approach. It's intuitive to use, but for storing a system, this is dangerous. And that's why people for applications came up with this idea, or it's not people of the applications, it's Edgar F. Cott himself in 1970 when he introduced the relational databases. He also talked about normalizing. We have to reduce redundancy, and there's this like third normal form, 3NF, and Boyce-Codd normal form, and that's the fifth and sixth and whatever normal form. Usually application databases are in sort of third or Boyce-Codd normal form, where you reduce most of the redundancy. And in my example, I would have to split up this in 4 tables, right? One table would the product table, and the product table would then refer to the subcategory table, and the subcategory table would refer to the product table, and then I would have a sales table which refers to the product table. So instead of one table, I now end up with 4 different tables, which makes the model much more complicated. Yeah, star schema. Thank you very much, Fernando. Hope everybody of you read the book mentioned in the chat. If not, buy it today and read through it. It's a really, really genius book. And now with normalized form, like writing queries is really complicated because we have to write a select blah, blah, blah from sales, join to product on something, join to subcategory on something, join to product category on something. So the queries get much longer. It's much, yeah, there's much more chance to making errors and mistakes in there. And also for the database, it's much more effort to go to one table and find the key in the other table and then again and on. So all the queries will be slower. For application databases, this is not an issue because this is mostly about like adding things. Of course, they read also things and some other things, but it's also about adding most things about creating and updating and deleting stuff in there instead of just reading it. And as is a problem, so the single table approach, a lot of redundancy, normalized schema, no redundancy at all, but really complicated to query. So the intermediate solution here is this denormalized schema. Again, don't think too much about the term denormalized, but it reintroduces some of the redundancy. It does not mean that we go back to the single table. It's meaning that for the dimensions, we have redundancy. So the dimension tables, whatever those are fully denormalized. So this is like not in third normal form, but the fact tables stay in third normal form. So we keep the facts normalized, but the dimensions totally denormalized. If they're not totally denormalized, we will talk about Snowflake schema. If they're fully denormalized, then we have a star schema. So only a relationship between the fact table and all the dimensions, but the dimensions do not have further relationships. That's a star schema then. Again, those terms, I think Mr. Kimball, Ralph Kimball invented all those terms. So the single table would be a really wide table, right? So I have the column names in here. So think about this as a wide table because the columns are in the columns, but in this list view, we see the column names in there. Huge table, lots of columns, and we replicate everything because for every sale or effect we're happening, we're repeating everything: the date, the month, the year, the customer, the name, the whatever zip code, and so on. And that's what we do not want to have. In a star or Snowflake schema, we distinguish between the dimensions and the facts, as already mentioned. So what's a dimension? A dimension would be an entity or a table which answers questions like how did something happen? What happened? When did it happen? Where happened it? Who was involved? Why did it happen? That's the things we currently or mostly filter on it. So if you put a filter in Power BI or you think about a report, you want to filter on something, most probably it's a dimension. Maybe you want to have something on the rows or the columns or on the axis of a chart. That's a dimension because we want to filter and group on them. Compared to the fact tables, the dimension tables are relatively small. I mean, relative is also always relative. I worked for Runtastic, like a running app. When I left the company, we had 200 million customers. So the customer dimension was 200 million rows, which is not a small table. But compared to the facts we got every day, it was comparably small. And they're always on the one side in the model, and they can have columns of all sorts of data types. So there could be text, of course. There could be numbers because there's a zip code in there or something like that. There could be like a price, so there's a decimal there. So all kinds of data types are there. Very important. They also have a primary key because in the facts I refer to the dimension table. So I need something which I can put in the sales table to refer to connect to the dimension table. The effects, on the other hand, those are, I think, the most important thing is this real world events. It could be measurements, details, transactions, but there's something happening in the real world. Think about a supermarket. If you go to the cashier and put all your goods, I don't know the terms right now. So if you put the goods there, they just take the good and then they make beep on the cashier. Every time it makes beep, that's a transaction, a row in the transaction table, in the fact table. Something in real world happened. So we know now that this product was sold to this customer, if you know a customer ID card or something like that, in this place for this price and whatever information we have at this point in time, which we can then connect to. So they're the meat of the model. We can aggregate, typically we aggregate on them. So we aggregate the sales amount or we count things. So there could also be fact tables where there's no measurement in it. Think about like the same supermarket. We could have like a sensor on the entry and if you're leaving, so we could like count how many people are coming in. We don't know what kind of people came in, what they earn, how tall they are, what they weigh. We don't know, but we will know there's a count in there. So we just have those captures of those transactions, of those events, and then we can count on them. And again, aggregate on those counts. Compared to the dimensions, they're always big because if I have a lot of customers, hopefully those lot of customers have a lot of sales, each of them. So of course, then the number of facts is much bigger. So on the many side in our model, and usually they don't have a primary key because this compress is not really good. If you can avoid the primary key in here, it's good. And we're never referring to the fact table. So you should not have a reference to the fact table, only going from the fact table to the dimension tables, which means we have a foreign key, which is then foreign keys, which are referring then to the different dimensions. So what happened, when it happened, where it happened, and a lot of numeric columns typically. So usually we don't have any strings in there because this would be stored in the dimension. But a price, a quantity, score, whatever. The star schema would be if I have a fact table and I have dimensions around it. And I think the term star comes from, with a little bit of fantasy, you could like have a 3-pointed star, you could see something like that here. I know you need a lot of fantasy for that, but that's the idea why it's called a star schema. That means that I have a fact table in the center. You can see this like on the many side of all the relationships, the dimensions on the one side around territory, date, and product. And those tables don't have any references to other tables. That's a star schema. And that's what we should go for. And it's not so much because the star schema is so much better than all the other things or because you trust me or whatever. No, it's because Power BI and the Vertipack engine behind, the database behind, analysis services, also the column store index is optimized for a star schema. So if you want to do yourself a favor, please model things as a star schema in Power BI because this is what always will be easy, always will be fast because it's optimized for this kind of schema. Maybe in some occasions, you could have a Snowflake where you decide that you then want to split up the product into subcategory and category. So we have a normalized dimension now. This is not denormalized, this is still normalized, but this comes with the backdrafts. Because if I put a filter on here, of course, this filter has first to propagate here, and then here. So this will always be slower than having the filter directly on here, which has only one relationship to propagate to. The other thing is that all the tables, remember, if you open a Power BI or connect with Excel or whatever tool, you see for all of the tables, you see a folder in the field list. And then you can open this folder, expand the folder, and see the columns in between. And all those tables are folders. So it's now much more complicated for the user to find out if I'm looking for something, a list price. Is this stored at product level, or do we have list prices at subcategory level? So it's much more complicated to use the model if you have a lot of different entities or tables connected to the same idea. So I have to look through all those tables to find this. And the other thing is if you want to build a hierarchy to make to collect different columns to put them into the report, you cannot do this over several tables. You have to have them in one table. I think I forgot one of the disadvantages which we can see here. So we have more tables. It takes longer to load. Also important because if I just load 5 tables, this will be faster than loading 7 or 15 tables. then much slower filtering, and the field pane in the end user's tool will be less intuitive. Hierarchies are not possible with different columns. So I did just a short, this is not really to be a scientific thing, but I was just curious to put the same information, like it took AdventureWorks with the territory, the date, and the 3 product tables, and model it as a single table. So denormalized everything, kept it in the star schema. So I denormalized only the dimensions or the Snowflake schema. So I kept it like it is by default. The AdventureWorks says always this dim product subcategory and category table. And to my surprise, the size of the model was much larger than I would expect. So even if we have VertiPack and everything is highly compressed, this model was almost 3 times and bigger than the star schema and the Snowflake schema. This surprised me, to be honest. And when I think about the relationships, as we don't have any relationships in here, of course, we don't need any space here. For the star schema, we have 4 tables, so there's 3 relationships. Of course, this takes up some space. Those relationships are persisted in VertiPack as a sort of index. Think about an index. So there's like a list of all the keys from the one table with all the corresponding keys in the other table. So it's making the joins and the lookups and the filter propagation much easier. And of course, if in the Snowflake we have more tables, so there's more relationships, it's a little bit bigger. Compared to the overall size of the model, it's really neglectable. And think about there's no relationship, this is much bigger. So this should also be an argument, stay away from this Franken table, this single table approach, and at least try to do a Snowflake optimized things would be the star schema. And how could you do that? There's several ways. For example, you could use Power Query. If you have to load different Excel spreadsheets or CSV files or whatever you get as a data source, use Power Query to make everything nice and crisp. That means filter your data, choose friendly names, make sure that the data pipes are the appropriate ones, and then flatten your dimensions. So if you, it's the merging. Yeah, so you merge all the other tables, all the other dimension information into this one dimension. And stay away from flattening the facts. That means normalize the facts. So depending on whatever your data source is, if it's like Excel, then most probably the important part is to keep the facts and move away the dimension attributes to it. If you're connecting to a relational data warehouse where somebody built a corporate what's called a corporate information factory, yeah, the CIF, what Bill Inman is like suggesting. So you have a data warehouse in third normal form, then usually you have the problem that the facts are already denormalized, but also the dimensions are, the facts are already normalized, but also the dimensions are normalized, and then you would denormalize those. Either use Power Query for that. You could also use DAX for that, but in DAX it's already too late, to be honest, because then we already load the data in the wrong format. And then of course we could like copy things and have the latest, the shown version of the model in the right format, but we have all those up tables still in the model, which increases the size of the model. Or if you have a data warehouse, of course, the latest point to do that would be the fuse. So you connect Power BI not to the tables. Please don't connect to the tables. Always connect to fuse. Think about that the fuse are the API to the data warehouse. And this would be the latest point to do exactly that, to end up in the star schema. And the fuse gives you the freedom that you later on can change everything in the data warehouse as long as you make sure that the result set of the view is still the same. And if you want to change something, you just create a new bunch of views, give your report developers time to change from one API to the other one, to change from one version of the views to the other ones, and then you can get rid of the old views later on. And this is coming 7 minutes to go for the data dimension. So the data dimension is important because we need it for convenience. If you talk to people in a relational data warehouse, they will ask you, why would you model a data dimension? I can always apply functions in my select statement to the date column and then extract the year or the month or put it in different formats. There's this format function, right? But this is what we do not want to do for the report consumers. Those people building reports, they should have a nice time. They should just pull in things they need. So one thing is for convenience. We want to have a data dimension with one day for the whole year, and then all the thinkable attributes. So the year, the month, the day, the working day, the name of the day, if it's a holiday, all the different formats for the quarter, and so on and so forth. Whatever the report user uses and needs, please build a data dimension and put in a column in there. Of course, this increases the size of the model, but if you think about the data dimension, it's 365 or 366 days a year, so 10 years, not even 4,000 rows. This is really neglectable in most of your models. The other thing is time intelligence. If you want to use the built-in functionality in DAX for time intelligence, you need a table which has 1 day for every day in this year. So don't build this table on your facts, because maybe you're not selling anything on weekends or on public or bank holidays. So really build this from scratch, either get it from a data warehouse, use Excel to make something up. There's also really cool scripts in DAX or Power Query available, but please build a data dimension with 1 day per year. 1 row per date. Sorry, it's really late for me. In Power BI, please be aware that this auto date time functionality. So if you load something, it will discover, oh, this is a date time, and then will automatically build this hierarchy for you, where you have the year and the quarter and the month and the day. And if you use this, you get also this interesting logic or interesting references where you have like the table name dot, column name dot, and then it tells you year or month or quarter or day. Please don't use that. It will potentially increase the size of your model, because it will implicitly and behind the scenes, you can't really see it inside of Power BI, build a date table for every single date column in your model. So if you have, for example, like, I don't know, the birth dates of your employees, and the oldest employee is like 60 or 70 years old, then it will build a date table for the past 60 or 70 years. And it will do that for every single date column in your model. So potentially your model will be oversized. And the other thing is, if you change this later, then you get rid of this certain notation with this table name, column name, dot, day, year, or whatever. So if you remove this later on, it will break all your reports. So as mentioned previously, make sure that the data model is in the right way from the beginning. I understand why Microsoft built this feature. Microsoft wants to be like everybody included. If you never heard about Power BI, you just use it, making up stuff up there, and then you have like the year available. It's really easy to use, but if you go some steps further, it will like bite you into the back, or whatever is in English term for that. So not very good. Then you can build it like from the data source, use calendar function, calendar auto function. There's several ways to build it. And I'm afraid we will not talk too much, or at least we can talk about it, but I will not be able to show you the demo about the role-playing dimension and the multiple tables, which is typical for a data dimension. So you might have like a order date and a ship date and a due date in your facts. And then the question is, how would I model that? Would I have just 1 date table or several date tables? Let's see about that. Also very important, make sure that you mark your date table as a date table. In some occasions, this might be not necessary, but the shortcut is always mark your date table, then you're fine with that. I have a demo about to demonstrate when it's really necessary, but we'll jump over that. So just remember the shortcut, always mark your date table and find out what's the date column in there. Yeah, the auto date with Vertipack Analyzer, for example, this is the Excel version of that. We can actually point out and see those local date tables created for you. And so make sure that you turn off for your current file, you can turn off or should turn off the time intelligence function, auto date time. And if you want to make sure that all new files also are turned off, then please go to the global section and also turn this feature off there. And thank me later. So role-playing, and this will be most probably the last thing we'll talk about today. So one way of having a fact table, this is the fact table, that's the date table. One way would have like, I have 2 dates references in here, order date, ship date, and I could reference to the same table twice. But as we can see here, there's one straight line and there's this dot, dot, dot line, this dashed line, which means this relationship is inactive because Power BI is silly or whatever. Does not allow us to have more than one active relationship between 2 tables. This is almost like in real life. Okay. It's really hard to have 2 active relationships in real life, right? And the reason here is that, of course, if it would be 2 active relationships, if I put a filter on there, the question would be, should it put a filter on here, on the other date table, on both, or whatever? This is ambiguous. It's not clearly to answer. So that's why only one is allowed to have. And if you have this kind of approach, you can then use DAX to activate the other relationship. So if you write your DAX statement, write calculate is our friend here, put in the measure we're talking about, comma, and then use relationship, date table, date column, comma, sales table, ship date column. So then for the sake of this calculation of this one measure, you will activate the other table and implicitly automatically deactivate the other one. So that's the one. So you have a simple model because only one date table, several relationships, and then you have a more complex DAX because you have to activate those relationships where you need them. The other way of having this would have to be two different or more date tables. With that, we of course have a more complex model because we have more tables in there, a lot of active relationships, no inactive relationships, but this comes with the advantage that we only have one measure and this works for all, and the report user can decide if they put the field on the order date table or the ship date table. So it's up to them then. And also like the way of reports you can create and visuals could create a little bit different with this approach than the other one. But we are right at 45. So it's important, that was my task for today, or I think this was I had in mind to really talk to you, to talk into you, to take care of your data model, because Power BI creates something for you and this will be fine in most occasions, but maybe not. Please always review what Power BI automatically creates for you. Stay away from bidirectional and many-to-many relationships and prefer the star schema because that's what Power BI is actually optimized for. And then you have, we did not demonstrate it for time purposes, but you can, in most of the cases, exchange complexity in the model with complexity in DAX. So either have a more complex model in simple DAX or more simple model with less constraints or less relationships, less tables there, but a more complicated DAX there. Links out there, we talked about that. And yeah, so when you have a shape data model, then your visuals in DAX will be much happier. And yeah, who cares about ad hoc data model, which was just built without thinking. So with that, thank you very much. Ran through in 30 minutes, about 30 minutes. If you want to contact me later on, please add me on LinkedIn, follow me on Twitter, send me an email, shoot me an email. I will also share the slide deck with Ben and Alex. And if there's any questions, of course, I'll be here.
Thanks very much, Markus. That was brilliant. Any questions for Markus? Yeah, we've got one. If you shout it to me, I'll try and repeat it. So how do we deal with multiple fact tables in the data modeling approach?
Yeah, that would be like the budget case I've used of that would be one of the use cases. So in the budget scenario, you have like the actual sales, and then you have a budget, and the budget is never ever on the same granularity than the actual numbers, right? Because you do it only on the month level and only on the product category and whatever. And then you have like two fact tables on different granularity in the model, and then you can join them on common dimensions. So everything which is in common works. And for the others, you have to find some tricks. One trick is, and I can show, I mean, I can stay here as long as you want me. So let's point out to the budget use case, which I jumped over, which is like the 3DS to start with, and then we can jump over to the bridge table. So there's three different solutions what you can do. You can have a many-to-many relationship. You can use DAX again. Yeah, instead of having a many-to-many relationship, you can stay away from the many-to-many relationship and use treaters, which is a DAX function. Or what I prefer, that's the third, is the bridge table. But let's take a look on what's the problem and how the solutions could look like. So this is this one. Give it a second to load. Again, the bridge table, I want to jump over to the other one. Doesn't really let me. No, so here we are. So I have a sales table here with 4 different rows, really easy model, right? With 3 different products and different amounts. And then we have this product table in here. And for the fourth one, we don't have any sales. And then we have the budget table, and the budget table is not connected to the product table. So the model here looks like this. So I made it that it's actually connected. Let me think here. Why is this connected? I don't want to have this right now. So I saved it, obviously. after I changed it. So with the budget table, the budget table in this case, just to make everything easier, is connected to the date level. So I have a budget on day level, which is unusual, but I just wanted to have one stable connection, right? And only one where we have like to find out how we could connect it. And if you take a look on this report up there, we have like the month of June, actual month, and then we have these two groups of different products, and then we see a sales amount of 33,000, which is the 3,000, the 20, and the 10, which is happening in June for group 1, A and B. That's those. And we have the 15,000, which is the last one in here, and this sums up to 48,000. Very good. So for sales amount, we are done. For the budget, we have these weird numbers that we see the 27 in here 2 times, which is weird enough. I mean, this could potentially be happen, but we see there's like something wrong because this it's not summing up, right? 60,000 in here. And the problem is because there's no relationship between the products. So the filter from the month is applied to the budget. And if you take a look on June of 2022, this is the first 2 rows. So 20 plus 70 is the 27 we're seeing here. And you might remember, or hopefully you heard about that by default, the total is never the sum of something up there. The total, the difference between the detail rows and the total is that in the total, there's no filter. There's no filter context. So there's no month filtered. So that's why it's showing 60,000, because without any filter on the month, we have like 20 plus 7 plus 25 plus 8, which is 60,000, which you can afterwards calculate in your calculator. So the solution here is 3 ways. One thing is I could use 3 days. So I can tell Power BI, please, in my calculate, having a measure here or a calculation here, but the important part is this 3 days, please take the filter from the product group onto the budget. So there's no relationship in the model. So I did not create any relationship in here, but I create one on the fly with 3 days. And with that, I solve part of the problem. So I solve the problem that I now get like the budget for the group 2. So this is the wrong number, this is the right number, but I'm still missing group 3 because group 3 is not available. It's available in my budget. Jump back here. So I have a budget on group 3, but there's no group 3 currently available in my product table. This I cannot solve with the 3 days. I cannot create this new thing. The same is true if I just would create the relationship like we have previously here. So if I just connect the product group in here, then I get this warning. There's like a many-to-many and bidirectional. Yes, I'm aware of that. So every time, please read this carefully and rethink this. But I actually wanted this to be happen. So if a many-to-many relationship, bidirectional, from what I told you, please stay away. But for this would also work for the budget now. So in the budget, I also get this soft now. Where is it? No, it's soft now, not soft in here. Why it's not soft in here? We get the 33 in here. Let me think. 33 is right, 27 is also right, but this does not really help in here. So it does not solve our issue in here. I thought I had a solution for that. No, it's not really solving anything. Anyways, I want to jump anyways.
Inactive, Marcus.
Is it inactive?
Or what the new name is, weak relationship.
Yeah, it's weak, but it's inactive, and I cannot have it active. Okay, because we have the circles in here. Then okay. So we have a lot of problems in here. Thank you very much, Heron, for pointing out. But well, anyways, wanted to show the other one. So where I have a relationship between the product and the budget table. So I get the right things in here. So I have my groups 3 and 1, 2, 3. Get the right numbers, the summing up. So that's what I'm going for. And what I did here is having this bridge table in between. So I created, I think in here I created with DAX a distinct list of my products groups combined of my budget and in here and put this in between. So I'm getting rid of my many-to-many relationship. I'm getting rid of a bidirectional filter and just put a one-to-many relationship from this bridge table, so-called bridge table, to the others. And this is what you can do to combine things on different granularities to share certain dimensions. Does this answer your question? A long answer to a short question.
A long answer to a question, but Carlos, happy? Yep. Any other questions, thoughts, comments?
Marcus must have one fact about lints.
We'll forget the facts about lints that Marcus might have. Carlos, you were about to say something. Yeah. Okay, so you mentioned earlier about when we're looking at order date, shipping date, due date, etc., we could either have one date table and then use the use relationships feature in DAX, or we could have three date tables, three date tables, each one relating to each of those different dates in the fact table. Which is your preferred or recommended approach?
You know, I'm a consultant, so it
So it
depends.
depends.
Yeah, of course. It depends what the user actually needs, what we need in the reports, just opening those files, because there's other consequences other than having more complicated DAX or having the model more complicated. So with the, let's see what's opening faster. So I finished in time, but now I'm like taking much more time than planned.
Don't worry about it.
This is good for
I
me.
think it's fantastic that
That's okay for me.
we've got someone online. Yes, it's good.
Mhm.
We've got someone online who's got, you know, a model that will show us the answers to all of the questions. This is obviously a pretty experienced consultant. Not only that, unlike me, he's got everything organized and logical. There's no way I could find this stuff that quick.
Okay. So let's start with the role playing, because this was the first one we talked about. So I would have one date table, right? And then I have two different relationships. One is active, one is inactive. This just again to try to show this in the report. And we have then this active relationship on the order date and an inactive relationship on, let's see, on the ship date. So that's what we got, exactly what we have had on the slides. So for this model, if I filter anything on the date, it will only filter the order date. So that's the consequence in here. So if I have only filtered on June, for example, it will filter the order date, but the ship date, which is in July, totally ignored. There's no filter put on that. And with that, I can build reports like that, where I then have like my two measures. And usually I would not create a quantity which is based on the default and a order quantity which is on this use relationship. I would actually put two measures to make it really clear and explicit that this measure is dependent on the on the shipping date, and the other one is with the use relationship on the order date. So that's what I would put there. And then we can have a report which actually show on one chart for the different dates what was ordered, what was shipped. So this is possible with this approach because we have two different measures, and I can have one single date dimension and put on those different measures in there. Or I could show it like in a table like there, where I see like this was ordered there and then shipped somewhere later. So that's possible here. With the other approach, if we need this, perfect. The other approach, which has like two date tables, one order date table, one ship date table with two different relationships in here. With that, we have the pro in here that we can have two different filters. One filter is filtering the order date, the other one is filtering the ship date. So I can have like limit things in here or expand things in here. So put this again on the first or whatever, if the filter would work. And what I could also put is I could create a matrix where I put one date on the columns, the ship date on the columns, and the order date on the rows, and then see in one single table how this order were then when shipped. The orders on this day were shipped like on the 2nd and 3rd of July, about 1 month later. But in the report or like in the chart, I have two different dimensions here, so I cannot combine this on one single chart. So that's the consequences in here. And what's right or wrong, I'm just a consultant, right? I have to ask the report users what they want to see, what they need. And of course, you can always like have like both approaches. You can have a date table and an order date table and a ship date table if you want to go full in here. Again, does this answer your question?
Yeah, I think so. Yeah.
3-minute answer.
Last question. Well, maybe not the last question, but question from the back. Say again, sorry. We're going to have a bit of an internal discussion.
Financial periods. That's yeah. I've got a
Bear with us a moment. We're talking dates. I'm going to ask your opinion in a minute. So the question that a little discussion we had here, Markus, was, is there a kind of standard date template out there, or how do people use that, specifically around, financial periods, which of course are different for everybody, but of course we might have our 13-week period of 445, etc. My personal piece is I always go over to SQL BI and I nick theirs, and then I just customize that heavily. I had one customer who worked in the UK on railway dates, which a railway week always starts on a Saturday. They also had a construction part of their business that started on a Monday. And then they had financial periods, which was something completely else. Like the financial year started on I don't know, 1st of April or whatever. And even just trying to get a report out for them, I had to make them think about what dates they wanted to see. And I started off with the SQL BI DAX piece and ended up with something that's pretty complex, but it kind of worked. Do you have any thoughts on that? If you've got complex date calculations, where do you start? And is there any way that you've ever found to standardize that?
Yeah, of course, yeah, there's no standard because the standard is whatever the customer needs, as you just pointed out, starting week on Saturday, unheard of for other customers. And exactly, I mean, there's this huge template file. It's really, I don't know, I think if you open the template file and you watch the date table definition they came up with DAX, I think Power BI mentions that there's like an error in it because it's just overwhelmed about the length. So it's also a good way of testing
Yeah,
things.
I've seen that.
And there they build also like all the different holidays, and I think there's also you can set parameters for the financial years and so on. So this would be a starting point. Of course, I would remove everything you don't actually need there. So don't take this template as it is, because this is like trying to cover everything. But this could be a starting point. There's also other, if you just use Google to find things there. There's also a Power Query you can come up with that. And of course, my go-to is if I have a data warehouse, I try to solve everything in the data warehouse already, so that if one place and don't replicate things in Power BI, in every Power BI report and every Power BI file again. But this is mileage may vary. If you don't have a data warehouse and you not really use the Power Query, maybe stick to DAX. If you already had your experience with Power Query, try to solve this with Power Query. So there's no wrong or right. In theory, always everything is done before, like in Power Query or before, might be compressed better. That's the theory in here, because like the Vertipaq engine tries to sort your data and find the optimal sort order of your data, so it compresses best. If you then have a DAX calculation like a table or a column, then this is done after the sort order was found. So it might not compress that good, but I think this is for many projects, this is really neglectable.
Right. All right. Listen, Markus, thanks. It's 8 o'clock in the UK. Therefore, it's 9 o'clock, obviously, in Austria, and
Yes.
possibly way past anybody's bedtime for the Austrians. So I'm going to say, listen, thank you very much. A quick round of applause from us.